Hello and welcome back to the Rustlings courses. We have left off at the topic of strings, and as always we will execute the Rustlings command like that, and you should see where we have left off in exercises strings 1. So I will open that up. And let me see, Rustlings, strings 1. That's it. So make me compile without changing the function signature. So we cannot change this signature. Let answer is a variable, and we will call this function. So this variable will hold the return type of this function. As we can see, this is the return type, so naturally this will be of type string, like that. Now this will return a string slice, so this is actually wrong, and then it will return here and it will print out this line. So in the terminal or in the output, we can see that actually expected struct string found string slice. So I've briefly mentioned it. There is actually two types of strings, and for one it's this thing here, and this is a string slice. So a string slice is basically a hard-coded string. So, for example, this is a string slice. This is hard-coded into memory. So these are fixed size and you cannot modify it. That's why we call it string slice. When you see that, it's basically hard-coded the string. This string is hard-coded into the program's binary. So it's firstly allocated in stack memory, and it's hard-coded into the program's binary. And the second one is the actual string or string object in other languages, and this is actually modifiable. You can extend it, you can put different functions on it, and this is basically the difference. And also a string object is stored in heap memory. And of course, this is not hard-coded into the program's binary. So that's just a small introduction. So the problem here is this is actually a hard-coded value, a string slice. So what we here actually return is that. But as we have written here, without changing the function signature. So we cannot change that. So we have to change that. And the simplest way is actually, well, actually there are two ways. The first one would be to string like that. It's compiling. There is also possible to owned. Should also compile. And to owned basically means, because this, as you might have guessed, is actually a reference. So this is not an owned string. We have to make it like that. And this would be an owned string. So this is why this function is called toOwned, because you will make this one an owned type. This one is just a reference. And also another possible scenario would be into. And basically what this does is it will convert this value into this value. This is also possible. Yeah, we have made that, but my favorite is to just put string from, and we will have blue like that. And as you can see, it's compiling. So as you can see, string from blue, and this is actually my favorite syntax. Of course, it depends. Sometimes it's better to use the other one like that, dot to string. You know, it depends on preference and also on the context of the code. So we have made that. Let me remove this one and strings 2. Okay, make me compile without changing the function signature. Okay, here again, let word is a variable, and we would store into it a string, because as you can see, try not changing this line. So this variable will hold green, this string of type string. Let me zoom out a little like that. And if is a color word, and this is a function call, which will call this function, and we pass this variable, which holds this string. So we call this function, we will go over here, and as you can see here, the function signature is actually wrong, because here it says we are expecting a string slice, which is not the case. But actually, and this is also an exception, let me put that over here. So there are coercions in Rust, and this means that Rust sometimes will coerce the types. So for example, this will get transformed into this. So a reference to a string object will be transformed internally. You don't have to do anything. This will happen automatically behind the scenes, will be converted to this type, a string slice. So what we can do is basically just go over here, and we will pass a reference of this variable, which is of type string, and not the actual ownership of the variable. And this will then convert the type automatically, so we don't even have to change anything over here. So let's see. And as you can see, that is a color word I know. And this is what is printed over here, because all these values, or at least one, because this is an OR operator, at least one of them is true. And in this case, this one is actually true. So this function will return a boolean which is true, and this line will get printed. All right. Next one. No assessment here. And it seems we just have to follow these to-dos over here. To do, remove white space from both ends of a string. So let me actually see what is happening in the tests over here. So trim a string. First we have to basically remove white space from here or from here and here, as you can see, and this will be the expected output. And the second one, compose a string, hello, hello world, goodbye, goodbye world. So we will just be appending world, exclamation mark. And replace a string. I think cars are cool. I think balloons are cool. I love to look at cars. I love to look at balloons. So here we have to replace cars with balloons. All right. So we'll start over here. To do, remove white space from both ends of a string. So we have here input, so we can take that, and there is a function in Rust, it's pretty handy, called trim. I'm sure those coming from JavaScript or TypeScript, they know already this function. And what we actually have to do, because as you can see, this argument is of type string slice, and we return a string object. So we have actually to use one of them. You remember, to string or into or to owned. So it's pretty much it doesn't matter too much. I like to use to owned, because what's actually the difference over here is this is not owned while this is owned, so it makes it a little more clear to me. You can use toString, but basically it's not so clear to me, because here we have a string, or kind of a string, and here we have a string. So what are we actually doing? It might be confusing sometimes, but as I said, you can use anything you want. To owned, to string, or into. It's all the same basically. So here we have the function compose me. Again, input string slice, add world to the string. There is multiple ways to do this. So we can, for example, make this mutable. So we take input and make it mutable like that. And also we have, of course, make it a string object, and I will use my favorite syntax over here. And what we basically do is we access this variable with make it mutable, so we can actually push string and we can put world into here. And then what we have to do is to actually return this modified string. All right, and the last one, replace cars in the string with balloons. So again, we have input argument of type string slice. So what we will do is take the input, and there is a function replace, and then the first thing is the value you will search for it, and the second one is the word you want to replace it with, and this will actually return a string, so we don't even have to convert anything. It will get converted automatically. So let's see if we made everything right, and as you can see, it's compiling. And yeah, I think it's pretty clear. These are not too big of a function, so let's move ahead. And this is actually already the last one. Okay, here are a bunch of values. Some are strings, some are string slices. Your task is to call one of these two functions on each value, depending on what you think each value is. That is, add either a string slice or a string before the parentheses on each line. If you're right, it will compile. No hints this time. So what we have over here are two functions. The first function will take as argument a string slice and will just print it out. And the second one will take an actual string or string object as argument and also will print it out. And we have now to decide if these actually are string slices or actual strings. So the first one is like that, and when you see something like this, you will know it's a string slice, because again, string slices, they are hard coded. So basically always if you see in a Rust program a syntax like this, double quotes and a word inside it, you will know this is a string slice. So next one, red. This is a string slice, but it will be put into the function toString, and this will make it an actual string. So this will be a string. Let's see. String from hi. So this is actually the same thing, you know. You can do both of them. They are exactly the same. And this will be a string. I personally like this syntax a lot more. It seems like more typical to Rust, but they are all the same. And this too, Rust is fun. This is a string slice, which will get into the function toOwned, and toOwned will make a string slice an owned value, which will be string, like that. Nice weather, string slice, into, and into will put it into a string. So that's that. Now we have this, and format should also put it into a string. All right, now over here, this is actually a little bit tricky. You have here an actual string ABC, and then you take these, the first one. So you take index 0 to index 1, but index 1 won't be included. So this will actually only take the first letter, and it only takes a reference. So basically what we will end up getting is actually string, right? String slice, like that. This will be a string slice because we don't own it and we take a slice of that string. All right. Hello there, trim. And actually trim just removes the spaces. It won't convert anything. So this will stay a string slice. All right, happy Monday to string. So this will be a string object. Replace Monteus. Okay. So this will be a string, as we have seen in the other exercise. Was number 4, I guess. Nope. This one. As you can see, the replace will actually return a string object, like that. And we're on the last one. My shift key is sticky, string slice to lowercase. Now actually, I guess this will be a normal string because we are modifying it, and it doesn't get modified in length, but it will get modified. So basically what this does is it will just lower the case of every letter. So let's see if I was right or wrong. And as you can see, everything is compiling. So blue, red, high, Rust is fun, nice weather, interpolation station. You know what? Let me see that side by side. I hope you can read it like that. So this will print out blue, red, high, Rust is fun, nice weather, interpolation station. This will print out A. As I've said, this will only take the first letter. Hello there. As you can see, the spaces have been trimmed or removed. As you can see here, we have replaced man with tu, and this will make it Happy Tuesday and not Happy Monday. And as you can see, the last one to lowercase, we have actually made it everything to lower case. So that's it. I will delete that. And we are done with strings. The next topic will be modules. See you then.